Hi guys, welcome back to YouTube channel Chemistry Lab UGPG. Today we are going to talk about mechanism of E1, E2 and E1cb reactions. So this is in accordance with NEP syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So this is the syllabus, fundamental of organic chemistry, major to minor to paper. So today we will be talking about mechanism of E1, E2 and E1cb reactions. So let's start with E1 reaction. So E1 stands for elimination unimolecular. So E1 mechanism was the first suggested by Hughes in 1935. So E1 mechanism is a two-stage process like SN1 mechanism. So first step is heterolysis of CX bond to give carbocation in slow step. The next is loss of proton to form carbocation from carbocation to give alkene. So here is the mechanism. So this is the halide. So first this CX bond will cleave, so it will give rise to carbocation and X minus, and loss of this proton giving rise to the alkene. So E1 reaction does not require the presence of a base. So rate of reaction equal to rate constant into the concentration of reactant. So it is first order. The carbocation may react with the solvent molecule SOS to form the substitution product. And the leaving group X include halide ion H2O, N2+, OCOR, quaternary ammonium salts, etc. The carbocation may undergo rearrangement to give a stable carbocation, hence the stable product. So suppose we start with this example, 3,3-dimethyl 2-butanol. So it would react with H plus and water. So here the OH has lone pair of electrons, so it will act as nucleophile, it will attack to the electrophile H plus. So it becomes OH2 plus. And first step is the formation of carbocation. So this CO bond will cleave on OH2 plus. So you generate this carbocation. So here water molecule is eliminated. So what would happen once we generate this carbocation? So there is the possibility that the water will take this proton and this CH bond will come here. So you will get this normal elimination product. Another possibility is that this methyl group can migrate to this carbocation center. So as a result, you generate a carbocation here. So that is called 1,2-methyl shift. So again, the loss of proton from this methyl group again give rise to this alkene, that is the rearranged product. And there is another possibility that the loss of this proton again give rise to the another rearranged product, this one. The next is E2 reaction. E2 stands for elimination bimolecular. E2 reaction mechanism was suggested by Hanhart and Ingold. E2 reaction is a concentrated process similar to SN2 mechanism. So E2 reaction mechanism involves the loss of proton and depart of leaving group in a single step, leading to the elimination of HX and formation of alkene as product. So E2 reaction was favored by a strong base and low polarity solvent. So here is the mechanism. So this is the alkyl halide and you need a base OH minus ion. So what would happen? So this OH minus ion will attack to this proton and here you will have a transition state. So simultaneously this bond will form and the depart of this CX bond will cleave. So you will have a transition state. So where simultaneous formation of this C double bond C takes place, giving rise to alkene. So basically the anti-elimination is favored. So here we take example E2 elimination. So suppose we take this trans product in presence of sodium ethoxide, it will be slow. So you will again get some amount of this alkene, and if you start with the cis product and you use sodium ethoxide, this is 104 times faster and you get the this same product. So here is the mechanism. So this OET minus from sodium ethoxide will take this proton and this bond will move here and it will kick out OTS as OTS minus. So here the anti-elimination is favored. So over the a scene elimination. So as a result, you get the product 100% faster in case of the cis1. So the faster elimination in cis acimer is due to the preference of anti-orientation of the leaving group, and that require a specific geometry, that is a coplanar arrangement of orbital. So here the scene elimination, here this is equatorial and this is axial. So OIT minus, and this CH bond will move here and it will kick out OTS as OTS minus. So again you get, so this is so next is E1cb reaction. So E1cb stands for elimination unimolecular conjugate base mechanism. So just like E1 mechanism, the reaction occur in two steps. First is loss of proton to give a stabilized carbanion, which is conjugate base. The next step is conjugate base facilitates the elimination of leaving group. Hence it is called E1cb mechanism. So here is the alkyl halide. So you require a base, and that again gives you the product, the alkene plus BH plus X minus. So here is the mechanism for E1cb reaction. So this base will take this proton and this CH bond will break on this carbon. So as a result, you generate a carbanion here. So this is the conjugate base of this one. So once you generate this conjugate base, so this C minus will come here and it will kick out the X as X minus. So leading to the product alkene. And this is the slowest step. So here is the example of E1cb mechanism. So suppose you start with this halide and you react with sodium hydroxide, you will end up with this product. So what will happen? This OH minus ion will take this proton and this CH bond will break on this carbon. So you generate a conjugate base, so carbanion. And this carbanion is resonance stabilized. So this C minus will come here and C double bond will break on this O. So this becomes O minus. So this is resonance stabilized. So once you get that carbanion, so this C minus will come back and it will kick out X as X minus. So this will form the product. So the leaving group is lost from the conjugate base from the starting molecule. So hence E1cb mechanism, the intermediate carbanion so formed need to be highly stabilized. So please subscribe to our channel Chemistry Live UGPG. This is the channel for class 11th and 12th students, Foundation Chemistry AB. So this is a simple step towards e-learning, making life better. Thank you all for learning.